Hi everyone, it's Jeff from Transient Specialists. Thanks for joining us today. Today we're going to be spending some time on the Teseq NSG 3040 test system. We'll start by going over a little bit about the transient generator, then we'll move to the connections in the front and back, and finally we'll spend some time on the front panel display. The Teseq NSG 3040 test system is a transient generator with capabilities for 4.4 kV combination wave surge and 4.8 kV EFT with a built-in single-phase CDN. This system is ideal for IEC 61000-4-4 and IEC 61000-4-5 testing, and has the necessary accessories allowing it to be used for other immunity standards as well. The model we're looking at for today's video is the NSG 3040-IEC. Let's go ahead now and let's take a brief look at the documentation. Now we're taking a look at the data sheet for the Teseq NSG 3040. Along the left, we have some key features, including capabilities that can be ordered with this system. As we mentioned previously, the model we're looking at for today's video is configured for both combination wave surge and electrical fast transient testing. As you can see along the left, this system can be expanded with different modules as well as used with a variety of accessories. While it's possible these units can have a custom configuration, it's most common to see the NSG 3040-IEC and the NSG 3040-SOW models. With the NSG 3040-SOW providing capabilities for the slow damped oscillatory waveforms of IEC 61000-4-18. When you're looking at this unit, it's important to determine how it's configured prior to ordering. If we scroll down now to the second to last page, page 4 of 5, we have information on the built-in coupling-decoupling network. This test system can be used with both the internal coupling-decoupling network as well as being able to be used with external coupling-decoupling networks. Taking a look in the middle section of the table with the EUT labeled by it, we can see our built-in CDN is limited to single-phase applications, up to 260 volts AC or DC, and up to 16 amps continuous. If higher voltage or current levels are used with this system, damage will occur to the CDN. If we take a look now at the bottom of the final page, there we have information on different testing requirements and related accessories. As you can see, external equipment is required for both IEC 61000-4-11 as well as IEC 61000-4-8 and 4-9. If testing is needed to be conducted to these standards, the corresponding accessories should be ordered with the test system. Let's go ahead now and let's take a look at the front of the unit. Now we're taking a look at the front of the NSG 3040 test system. Starting on the left, we have the EUT output connection. This connection will be going towards the equipment under test, and we include an adapter which allows for the plug on the front side to go to a standard NEMA style connection, which can be plugged directly into the equipment under test. Below that, we have the surge direct output. This will only be used for power off testing or to connect the NSG 3040 to a coupling-decoupling network. As we continue right, we have the burst output, which will typically go to a capacitive coupling clamp for testing data lines, and below that we have our grounding point. As we continue right, we have our colored display, and below the display we have the play, pause, as well as the stop button. Next to that, we have the sensitivity keys, which relate to the numeric values for the wheel. Finally, in the upper right-hand corner, we have a series of LEDs. The first is power on, then pulse, and high voltage. Below that, we have the EUT power on,
and our air LED. That should complete the front. Let's go ahead now. Let's get the unit turned around and take a look at the back. Now we're taking a look at the back of the NSG 3040. Starting in the middle, we have the EUT power input, which will be connected there to the back. Then go through our NSG 3040 and we'll have our EUT connected to the front. Next to that, we have our instrument supply input, and then above that, our power switch. As we continue to the right side, we have the Ethernet and system interface connections. Prior to conducting testing, the terminator will need to be placed in the system out interface, which you can see we have that connected now. Let's go ahead, let's get the system powered up, and let's take a look at the display. Now we're taking a look at the starting display. As you can see, we have different boxes for different tests. We have our unit configured for IEC testing, so we only have options for EFT and combination wave surge, as well as DIPS and pulse magnetic field testing, which will require additional equipment. Taking a look at the right side in the red box, we have buttons for system, reset interlock, and remote. If we go ahead now and we disconnect and reconnect our interlock terminator, you should see the red LED on the right side is now lit. To clear this error, we can go ahead and we can hit the reset interlock button in that red column and go ahead and let the menu run through real quick here. Alright, now that the menu is done, as you can see, the air LED is no longer lit. Let's go ahead now and let's take a look at the test menus by clicking on the burst icon. Now we're taking a look at the burst menu. We essentially have two columns in the middle with boxes around the outside. In the upper right hand corner, we have exit, which will take us to the main menu. And if we go ahead now and we look at the bottom, we have buttons for load user tests, load standard tests, save tests, and then in the far right, show graphics. If we go ahead and we click load standard tests, there we have different options for tests based on the type of line and the associated test level. We can go ahead now and just select exit. We can also manually adjust different criteria by using the touch screen and making the necessary adjustments. Let's go ahead now and let's increase the voltage to 2000 volts. Just like that, and we're using our turnstile, and let's switch the polarity to negative. The remaining test criteria can be modified in the same way. Let's go ahead now and let's take a brief look at the surge menu. Here's the surge menu, which is going to look very similar to the EFT menu, with the exception of including impedance, as well as a few other test-specific criteria. If we take a look now in the lower left-hand corner, we have the criteria for phase, and this is going to adjust the degree where the combination wave surge is placed on the AC sine wave. We can also select asynchronous, which is currently selected now if we're not concerned with the placement. The final functionality of the software we wanted to show is how to add steps and then how to see a series of steps. Let's go ahead and let's start with adding a step, and we can just keep the same default criteria and select add step, which is the second box down from the bottom on the lower right side. Now, if we take a look in the upper right corner, we have an indicator saying test step 1 of 1. Now, if we go ahead and we select show steps, this is going to list out the different steps that have been saved, and then you can adjust them, move different steps up or down, as well as delete them as needed. As soon as the necessary modifications have been made, we can go ahead and then select OK, and then it will save the changes. All right, that should complete the video today on the Teseq NSG 3040. We began the video by going over a little bit about the test system, then we moved to the connections in the front and the back, and finally we spent some time modifying different testing criteria from the front panel display. We hope this video has been useful, and please keep us in mind if you ever need to rent the Teseq NSG 3040.